Today we're going to save ourselves a few €100 by interconnecting and reusing all of our older electronics with our Raspberry Pi. Today we're going to expand our brain a little bit.
Come on, let's get going now.
Greetings, sailors, and welcome to a new episode of the Low Cost Sailor. In today's episode, we're going to reuse and modernize all of our boat's electronics thanks to our Raspberry Pi with Openplotter. Today we're going to upgrade our brain just a little bit. Our brain. It sort of comes out sounding like Dr. Evil.
Brain.
Today we are going to expand our brain a little bit.
Brain.
With that villain voice, they'll recruit you for the General Directorate of the Merchant Marine.
Today we're going to expand our brain. Well, actually, it's our boat's brain, of course. And we're going to give it some new senses and a bit more intelligence by restoring and interconnecting the older instrumentation our boat already has. We're going to give all of those parts a brand new life. Frankenstein, brain.
Please make another one, Frankenstein. Hey.
Frankenstein.
Better.
You have no idea.
Please delete it. Let's see Frankenstein.
It cannot be like this. That's how it is. Frankenstein.
As you can see, pretty much. Today we're coming back to the topic of the Raspberry Pi, and we're going to take a look at how to connect it with other devices that we already have. I do not know what your situation is like, but in my case, when I bought the boat, it already had a certain amount of electronics, which I am sure were very good and very expensive back in the day, but that become obsolete at an incredible pace. Also, because tech gets old fast and costs a lot, we can't update everything at once, so we update one thing first, and then one item comes from one maker and another from a different maker. Well, of course, they are delighted for us to buy tons of stuff. But in the end, we wind up with a real mishmash of mixed electronics on our boat, like what ends up happening to me on my boat. What the boat originally came with was a Navico Chorus speed depth transducer from the previous Jurassic era, where you could barely see the numbers, and with a bit of screwdriver work, internal cleaning and foam, I managed to bring it back to life so it would do its job. However, its communications protocol is completely unknown and totally undocumented. There is basically no way for anyone to really know how to connect it to anything at all. Then some later owner must have added a wind instrument, an autopilot, and a Raymarine chart plotter. The kind of wind instrument that does not have a vane, only the blades. It took me a very long time to get it to point in the correct direction where the wind was coming from. I even had to disconnect it from the autopilot because whenever I tried to tack using the autopilot, it worked on one tack but completely refused on the other. Well, in the end, it was all just a matter of climbing up to the top of the mast with my ladder from episode number, I don't know which one, cleaning the sensor at the top of the mast, and the autopilot was working again. The autopilot honestly did work, although on my first 250-mile trip, it left me stranded right on the last day. Well, the last night. It was just a matter of changing the belt, and it worked again. But I remember that night, and I always will. But in reality, it really did its job. It's just that it wasn't all that precise. Honestly, the boat did sway around a bit. And more recently, while I was rummaging around on the boat, I found a very old rudder blade position sensor with the wires cut as if they'd been ripped out. I fixed it, I got it installed, and now it works absolutely wonderfully. So we really should give that electronics we have lying around a second chance, dear. And lastly, the plotter. Well, the plotter is kind of like an abacus. It comes with one included, and you place it right there. And it comes with letters, doesn't it? The plotter is a chart roll, so you feed it through, you keep feeding it through, it turns, and the chart roll moves forward. Well, in this era of tablets and the latest generation smartphones, the truth is that the plotter that came with it looks like a Game Boy nowadays compared to what I can do with a Raspberry Pi. You wouldn't even imagine it. That was also one of the first things to improve on the boat. And of course, each of these devices communicated and used different communication systems. The CAN bus depth sounder. Navico proprietary, I have no idea how it works. The NMEA chart plotter, the wind instrument, and the Seatalk autopilot, and my Raspberry Pi. My Raspberry Pi speaks all IP protocols and lets us connect via Wi-Fi with any of our phones, tablets, and computers. So without a doubt, it is the best part of the whole boat.
The Raspberry Pi is cool.
Of course, and you can use it to play. Well, our goal today is to interconnect these systems so that all the information is centralized on our Raspberry and we can access it from anywhere, from the beach or even from home. So we are going to talk a little about the protocols. The first thing is to understand what they are and how they appeared in the world of boating. To connect two electronic devices to each other, normally you need to run a cable between them, and that cable required both devices to have compatible connectors, or to simplify it, that they actually had electrical compatibility and shared a common language to understand each other, which we will call a communications protocol. In the beginning, manufacturers would say, I'll just make up my own, so their devices could only connect with devices from their own brand, thinking that this way they could sell more, charge higher prices, and earn more. And that's what happens, for example, with the antediluvian protocol on my Navico Chorus fish finder. Over time, they started to come to their senses a bit and began to define some standards like NMEA, which inherited features from computer modem protocols. From the days when modems would beep if someone picked up the phone and you'd get scolded with, "I need to make a call."
My grandmother would go crazy.
And my mother?
He was saying, "What a noise, it's making noise."
Well, from those times, they already allowed two devices to communicate with each other, although they required a direct cable between the two devices. We will see that the simplicity of this protocol will allow us to connect these devices to the Raspberry Pi very easily and inexpensively by inheriting from the modem protocol. To improve this technology, bus communications emerged, which made it possible to connect many devices one after another using a single cable. The thing is that, at this point, some brands went back to making their own proprietary protocols. Seatalk, for example, but fortunately, and without the brand's help, some very clever folks on the internet figured them out, which will once again allow us to connect this protocol to the Raspberry Pi, specifically Seatalk 1. And finally, some more open protocols started to appear, shared among brands using a bus setup. With a single cable, they connected everything one after another, but they also made sure to use some nice non-standard and very expensive connectors so their marine business idea would not slip away. For example, we could mention the case of NMEA 2000, which is sold under other brands but is internally the same. We still will not be looking at it in this video, mainly because I do not have any device that modern. However, if a manufacturer would like to give me a fish finder to replace my Jurassic Navico, or what is more realistic, if some of you around the Santander area have bought a Raspberry Pi and have NMEA 2000 devices, then maybe we can make a video on your boat another time, connecting everything up with the Raspberry. Well then, all the standard protocols come into play, like the Wi-Fi our Raspberry uses, which makes everything more flexible and affordable, as well as some latest generation devices also very expensive, from marine manufacturers who are finally catching on and already include Wi-Fi features, Bluetooth connections to computers, that sort of thing. So let's get to it before Carlos kills me, because the video ends up being a bit too long. Let's go shopping. And to do all this, what are we going to need? First, we should have watched episode 11 and have our Raspberry Pi ready. If we have it connected to the internet via Wi-Fi, as we explained in episode 2, even better, because that is what will allow us to see everything from a phone, tablet, computer, or even from home. If not, that works too, because we will be able to see everything on the Raspberry screen. Now, to connect everything, well, cables. My recommendation for data cables is UTP network cable, the kind used to connect computers and that sort of thing. They are standard, inexpensive cables, and with a single cable, you have 8 wires, which is enough to connect many things, as we will see. Additionally, to connect NMEA devices, we will buy an RS232 to USB adapter, like this one for each device to be connected. For example, we can get 2 units for €4. There is no cheaper option, ma'am. And if what we want is to connect Seatalk devices, back in the day I bought a Seatalk to USB adapter on eBay for €35, but more recently I learned that we can also do it using a €2 optocoupler from AliExpress connected directly to the Raspberry, so we are going to take a look at both approaches. Additionally, you will need DB9 connectors for the RS232 adapters and some connectors and small cables of this type, so you do not have to buy the manufacturer's specific marine connectors, which is where they really overcharge us. Please remember that you have all the links in the description as we explained in another video. Let's get started with the assembly. As for the installation, the first step, and probably the most complicated, will be routing the cables from wherever we have our instrumentation to the Raspberry Pi. As some fellow YouTuber would say, if you have a Tupperware boat like mine, then you'll have to figure it out yourselves with cable pullers to find the route. And if you have a good quality boat, I suppose there's a direct conduit highway with a pull line that runs from there to your panel, so everything is super easy. In my case, I ran an 8-wire UTP cable from the helm to the switch panel where I have the Raspberry. We are going to connect 2 of the wires to Seatalk to receive all the data from the wind instruments and, in my case, the autopilot, or from whatever you have connected to this bus. I wish my depth sounder were at least Seatalk instead of Navico Chorus. I also accept old depth sounders if you are going to throw one away. Well, I will take basically any old thing you are going to throw away. I am basically a scrap collector. In our case, and following the instruction manuals we have been able to gather, we are going to use the green pad to connect to the green and yellow Seatalk wires, which are its data wires, and at the other end we will connect them to the input of our optocoupler. Finally, we will connect the other 3 pins of the optocoupler to the 3.3 volt pins. Pin 1 on the Raspberry, GPIO 4, pin 7 on the Raspberry, and GND, pin 6 on the Raspberry, as you can see in the image. Regarding NMEA, we are going to connect 2 things. The autopilot that supports NMEA input, which we will connect to our orange pair, the orange wire to NMEA plus, and the orange white wire to NMEA, which at the other end will be connected to pins 3 and 5 respectively of our DB9 connector. For the plotter, we will repeat the operation, but this time we have NMEA input and output, so we will use the blue pair for the NMEA input of our plotter and the brown pair for the output of our plotter, and both will end up connected like this to the pins of our second RS-232 adapter. You have a diagram somewhere that Carlos will provide showing how they're connected. If you are as skilled as I am, you may need a couple of tries to get it right and connect the output to the input and the input to the output, but please do not worry because you will not break anything during the attempts. Once you have connected the USBs to the Raspberry, everything will be fully ready. So let's move on to the setup process. Well, the first thing we're going to look at so we can work more comfortably with the Raspberry is how to connect to it remotely, whether from a tablet, a mobile phone, or a computer. If our Raspberry has Wi-Fi, but no internet, then we'll be able to do it when we're on the boat itself. It's as simple as enabling the VNC service on our Raspberry. We just go to the Preferences menu, Configuration, then under Interfaces, select VNC, set it to enable, and that's it. It may ask us to restart depending on whether it's the first time, but at this point we already have the service active. Now the only thing we will need to do to connect from our Wi-Fi network is install a VNC client on our computer. For example, we can download VNC Viewer, and once we have downloaded it, we run it and enter the address of our Raspberry Pi, which we can check here. And in my case, it will be 192.168.1060. This will also be very useful in the future for anything we are going to connect to the Raspberry Pi. We have a section here called Network Body, where under Bug Addresses and Ports, we'll be able to see all of the IP addresses and ports that we need in order to connect to our Raspberry Pi from different devices, either by using this name or by using this IP address. So, if we simply enter the IP address we saw here, it will prompt us to enter our username and password. And if we haven't changed them yet, I believe the username is Pi and the password is Raspberry. We can also click Remember Password if we want to, so it won't ask us again the next time. And then we'll be connected and controlling our Raspberry Pi, which we can do in exactly the same way from that tab. If you followed the advice from our episode 2, and we also have the boat connected to the internet, we'll be able to do the same thing from anywhere in the world. It's pretty easy too. We'll just go ahead and download the appropriate specific version of the AnyDesk. We'll choose the right version specifically for Raspberry, and we will download the most recent available version of the DP. We currently just have the AnyDesk file that we downloaded, and it's sitting in the downloads folder. Just double click on it, we'll tell you we want to install it for you. The administrator password is required, and at this point it's already installed. We'll go ahead and restart. And here we already have our AnyDesk installed. The only important piece of information we need to know is this, and we will need to set up a password. And here we enter the password that we want to use for connecting remotely and securely. Alright, and with this, we now have our Raspberry Pi set up and connected to the internet so we can connect from anywhere. We simply need to keep in mind this specific number that Carlos will have censored. So we are going to give it a try. We will have the AnyDesk client installed on our PC or on our tablet or on our mobile phone. We will simply enter the address we want to connect to and the password, and we will already be connected to our Raspberry from anywhere in the world without opening any ports or anything like that. It is very simple and it is also free, and you have AnyDesk client apps both for PC and for your mobile phones or tablets.
Wait, hold on. Does AnyDesk actually pay us for doing this?
What else could we possibly get someone to pay us for doing? Not for this anymore, for something else. Well, with this we can now view the Raspberry Pi from anywhere and continue with the configuration steps for our Seatalk and NMEA interfaces. Setting all of this up is very simple. Especially for NMEA, we are going to configure the one we have connected to our chart plotter. We simply go to Openplotter serial, and the list of serial devices that we already have connected appears. In our case, the GPS, we will also see the Seatalk using the simple method and our solar panels. In your case, it may be that none show up because you don't have any yet. Now we simply plug in the USB of our RS-232 adapter. We click the refresh button, and then a brand new connection appears right here. We click on it, and then we assign it a clear alias. For example, we're going to enter Pota Ray Marine, which will be NMA, and we're going to remember it by its position. We always have to plug it into the same USB port on the Raspberry or the hub. We click apply. It has to be in lowercase. Now we have it. We go to connections, it shows up here, and now we simply tell it that we want to add it to Signal K, that the connection speed is 4800, which is the NMEA standard. We select auto, and that would be it. Now, to verify that the data is already coming in, if we have the plotter or the device that outputs NMEA turned on, we can go here to Signal K, and here we have our Ray Marine plotter that is already transmitting data. We can repeat this same process for all the other NMEA devices we have, the NMEA 0183. Now let's move on to Seatalk. It's very simple. If you've chosen the easy way, the really easy way, which is the one I used at first, you take the $35 Seatalk USB adapter, connect the labeled pins to the two Seatalk wires, and plug it in as if it were NMEA. The only thing that changes is the connection speed, which in this case would be 38 to 400 pps. If we choose the even cheaper optocoupler option, we will install the Raspberry's GPIO option. We will go ahead and install it. We already have it installed. Now we will go to the GPIO menu. We see a Seatalk option and we will add it. We will add the option and we will select GPIO 4, which is where we connected it. We will politely tell it to, we'll tell it to invert the signal. All set, we'll proceed to approve the device. and then we click Approve. Dashboard. And here we already have our optocoupler working. You can see that it is receiving data, and if we go to the data browser, we should have our wind speed and direction here all with one device. Just that simple. Let's proceed with the tests. Alright, that's it. We've already connected a bunch of things to our Raspberry, us, the ones we have, you, the ones you have, and now we can view the data from multiple places, really, thanks to the remote connection from anywhere. But basically from the Signal K status by opening it on the Raspberry or in any browser under the data browser option, you'll be able to see all the data it receives. There is also a section that tells you where it is pulling the data from, so you can check each of the things you have connected. Also, Signal K itself allows us to create our own instrument-style display screens, our dashboard with all the data, so we can configure it however we like.
And of course, we can easily see everything we need in our usual navigation apps, either by opening them on the Raspberry itself or on any phone, computer, or tablet connected to the boat's Wi-Fi. For example, OpenCPN, so it's easy. We add a new data connection, enter the IP address of our Raspberry Signal K server, which we can see on that network screen we mentioned earlier. OpenCPN is already receiving the data, and we can now see all the data coming into the Raspberry, both the AIS data from our episode 11, which is so useful, and the ability to overlay whatever indicators we want on the screen. For example, in our case, wind speed, wind direction, and so on. All of this is truly useful for being able to navigate using the Raspberry as a plotter, or with the Raspberry transmitting the data to a tablet or a phone that we use as a plotter. With Navionics, we can do it as well. We will add a new connected device and it will ask us for a name, the IP address and the port, and whether it is UDP or TCP. We will take all of this from the Raspberry screen, from the Signal K NMEA output option. We enter the data in Navionics, and if we have an active subscription, because if you do not have an active subscription, it will not display it, it will then start showing us the boats, and even in the latest version, the depth from our sounder, provided we have managed to connect it.
If you are fortunate enough to have a probe that can actually be connected, unlike me. Carlos is probably fuming. He asked me to write a short and easy episode because he really wasn't in the mood to work, and since last week we recorded things a little bit late. But anyway, I've left quite a lot of things in the pipeline for future episodes about the Raspberry, such as being able to view the cameras through it, receiving weather reports, connecting temperature sensors for the fridge's healing batteries, the tachometer, and all the solar panel data. Well, there are quite a few more things we will be showing in later episodes. As for today, well, it is not the simplest thing, especially the Seatalk part, but it is really amazing to have all the data brought together. I'm telling you, the only thing I really miss is being able to have the depth sounder, since mine is just too old for now, but that would be absolutely amazing, because you could be lying on the beach watching the boat, keeping an eye on it from your phone with the cameras, knowing the depth, whether the wind is starting to pick up, whether the boat is dragging anchor, and as we'll see in future episodes, even being able to interact with the control panel, or having the windlass let out a bit more chain, or working together with the autopilot. So our old-fashioned, outdated instruments become the latest in technology and start offering things that B&G units costing many thousands of euros still don't offer. I hope today's episode didn't seem too complicated. You have screenshots of every screen and the detailed steps on our website, and you know I'm always willing to help you in any way I can through the comments. We'll be back with more Raspberry episodes, and we'll go into more detail and address questions in the Q&A videos, although we'll keep alternating with sailing videos and other more entertaining ones, since I'm sure someone has thought this one was a bit heavy. Well then, there will be a bit of everything. Thank you very much for your kind attention, sailors. I really hope you enjoyed today's episode. If so, please
give us a like, subscribe to the channel if you haven't already, and click the bell so you receive notifications about our upcoming videos, which in any case will be in 2 weeks in a new episode of The Low Cost Sailor.